Welcome to our final project video presentation featuring calculus made easy, seamless differentiation and integration with Python.
I am Team Margaret D. Marco.
I'm Armela Monique D. Martin.
I'm Ishamay Disim and we are the Group 6. Are you one of the students who find mathematics challenging? Well, you're not the only one, and this is a massive challenge for the Philippines as it is the Philippines ranked lowest among 58 countries in Math Global Assessment. Only 19% of Filipino students were on the low benchmark, which means that they had some basic mathematical knowledge, while 81% did not even reach this level. According to first-year engineering students, differential and integral calculus are among the hardest subjects which fail oftentimes, thus causing them to spend more time studying such courses. Indeed, math is challenging, but we are here to make it easier for you with the help of our calculus made easy, seamless differentiation and integration with Python.
Calculus Made Easy is a cutting-edge project which aims to revolutionize the way calculus is taught and used in the field of mathematics and math, especially engineering. This project makes use of the flexibility of Python, a programming language, to empower users to perform differentiation and integration operations on mathematical functions effortlessly. In addition to that, this can offer a tremendous aid, especially to our fellow engineering students who may use this program to further practice and develop their calculus skills.
The primary goals of calculus made easy, seamless differentiation and integration with Python are summed up as follows. First, to provide a user-friendly Python interface to make it easier to conduct differentiation and integration operations in calculus. Second, to allow users to quickly and accurately compute the derivatives and integrals of mathematical functions. Third, to enable consumers to visualize calculus processes so they may better comprehend how functions behave and how their derivatives behave. And last, to assist users in learning and comprehending calculus principles and how they are implemented with Python. Provide thorough educational resources and including tutorials and examples.
Not everyone is familiar to using Python codes, that's why this is the pseudocode to give us specific steps. Pseudocode is an informal high-level representation of the actual code that shows how an algorithm or computer program works in plain English. First one is to import the simply module. Next one is define a function called differentiation that takes in an expression in the high variable x as input parameters. Inside the differentiation function, calculate the derivative of the input expression with respect to the variable x. Next is return to the derivatives. Define a function called integrate that takes an expression in the variable x as input parameters. Inside the integrate function, calculate the indefinite integral of the input expression with respect to the variable x. Return the integral. Then prompt the user to input an expression. After that, prompt the user to input a variable with respect to which the expression should be differentiated or integrated. Next, create symbol objects representing the variable. Then display a menu of choices for the user, including differentiation, integration, and quit. While true, do the following. Ask the user to enter a choice. It's either A, B, or C. If the choice is A, then the following. Print the derivative of the expression with respect to x and plot the derivative. Else, if the choice is B, then do the following. Print integration. Ask the user if the expression has limits. If the user enters y, then do the following. Ask the user to enter the lower limit. Ask the user to enter the upper limit. Calculate the indefinite integral of the expression from the lower limit to the upper limit. Print the result. Else, if the user enters n, then do the following. Calculate the indefinite integral of the expression. Print the result. Else, if the choice is C, then do the following. Exit the loop. Print exiting. Ask the user if they want to do another calculation. It's either yes or no. If the user enters no, then exit the loop. Lastly, end while.
So before we start our simulation, here is a flow chart to express graphically the flow of our program. Since this is a calculator which will enable us to differentiate and integrate, it will start from inputting the expression. After we input the expression, we can declare its variable. So it is either with respect to x or with respect to y. But either of the two, we will always come down to our select operation, which we have three options. We can either start differentiation, integration, or we can quit and exit the program at once. So first, if we choose to do differentiation, since we have already encoded our expression, the print derivative will start wherein we can see the answer or the derivative as well as the graph that it has. So next is if it comes to integration, if we are going to choose the second operation, which is integration, we will we will be able to answer the question, do you have limits? Since integrals have two kinds, the definite and indefinite. So if you answer y, which stands for yes, it means that we are dealing with definite integrals. So we will be inputting our lower limit, our upper limit, then after that, we will be printing the answer which is definite as well as its graph. And then if we decided to use the operation to find the indefinite integral, then we will have to type n and then it will print the answers along with the graph. But if we decided to press quit once again, it will end or it will stop the program at once. So after any of that operation, we will arrive to a question that let's do another calculation. It is up to us. If we are going to say yes, then we will go back to selecting our operation. But remember that the expression you input first will be the same. You just have to change the operation. And if you say no or if you type no, then the program will end. So to further understand this, you may watch the simulation after this. But before we end, here is a here is a quick reminder that this project or this program to is not made to encourage students to cheat using this calculator. It is just a tool for us to receive the help that we need, especially if we are doing or if we are studying alone and we want to check whether our answers are right or wrong. So we can use this calculator to validate and to ensure that our answers are accurate. Welcome to the simulation of calculus made easy, seamless differentiation and integration with Python. What you are seeing right now is the source code that my group and I had created for this project. We will be skipping this since we have already discussed the pseudocode along with its flowchart. So let's start by entering our expression, which is y is equals to x squared. Since this is how we will encode it. Encode x, double asterisk, and then its exponent, which is 2. Next, with respect to x, since our expression is y is equals to x squared. We enter again, and then we choose our operation. So let's start with differentiation. Okay, so here we can see our the answer, which is 2x along with the graph. So we can now move to our next calculation. So we just press yes. So this is the same expression, but we will be trying another operation, which is integration by entering letter T. Since there are two types of integration, the definite and indefinite integral, let's start first with definite integral that has limits, so we enter y. Let's say our lower limit is 0, our upper limit is 2. Here we have it, our answer, which is 2.67 along with its graph. So next we are going to try another calculation, so let's press yes. Here we are going to try integration again, but this time we are going to say no to limits because we are going to try indefinite integrals. Having said that, our answer would be x cubed over 3, which is, if you have a background on differentiation and integration, is you can definitely say that this program is accurate. Now that we have tried all the operations this program can offer, we can now say no, and that is where this simulation ends. Thank you for watching! But this calculator does not give you the opportunity to cheat. You may use this to improve yourself and not otherwise. I think that's all. Thank you for watching.